So here we are asked to compute the derivative using the chain rule. And when they say use the chain rule when computing a complicated derivative of the integral, they just mean they want us to use a specific formula, and the general formula looks like this: t dx of integral with limits a of x and b of x, f of t dt equals to f of b of x times b prime of x minus the whole thing repeated with a of x. So t dx 0 x squared ln so our f of t is this whole thing. So this is where we're going to be subbing in our numbers. So let's sub in the first number, which is x squared. So ln 5 plus x squared squared, right? Times the derivative of our b of x function, which means 2x minus f of a of x. F of a of x is going to be ln 5 plus 0 squared, and the derivative of 0 is going to be 0. So this just cancels out. And so we're just left with 2x ln 5 plus x to the power of 4. Okay. So again, they're asking us to compute the derivative, and we're going to use the same formula. dx a of x e of x f of t dt is equal to f of b of x times the derivative of b of x minus f of a of x times the derivative of a of x. So, and we're just going to plug it in. T dx, sorry, this was supposed to be here, of cos x to sine x ln 1 plus t squared dt is equal to, we're going to plug b of x into f of t. So f of t is this thing. So we're going to plug it in, ln 1 plus, so sine of x squared. So when we're plugging it into ln of t, we're only plugging it into the t, and 1 stays because 1 is a part of the function and t is a variable, and we're only plugging it into the variable. So ln 1 plus sine x squared times the derivative of sine x, which is cosine x, minus ln 1 plus cosine x squared plus the multiplied by the derivative of cosine x, which is negative sine x. So in the end, we have ln 1 plus sine squared x cosine x plus ln 1 plus cosine squared x sine x. So again, we're going to use the same formula. A of x and b of x, f of t dt equals to, according to the chain rule, right? If you plug in that b of x, then you have the derivative of b of x you have to account for. And same with a of x. So let's do this example. So e, we're going to plug in negative x squared. And we're going to square it. Times the derivative of negative x squared, which is minus 2x, minus e x squared times the derivative of x squared, which is 2x. So we have e to the negative x to the power 4 negative 2x e to the negative x to the power 4 minus 2x e to the x to the power 4. And the last example, which we're going to use the same formula for, e of x f of t dt equals to f of p of x times b prime of x minus f of a of x times a prime of x. And okay, so let's evaluate. So sine of square root of 4 times the derivative of 4, which is 0. So it cancels out, minus sine derivative of 2t times 2, because 2 is the derivative of 2t, and so we have minus 2 sine square root of 2t.